Video 2.7b is all about something called hydrates. I really want you to pay close attention to this video because it is going to describe in detail a lab that we are going to do this coming week. So by the end of this video, hopefully you'll be able to define the terms hydrate and anhydrate, um, and then have a good insight into our lab we're going to do this week. Hydrates are compounds that contain a specific amount of moles of water attached to them. This is copper sulfate, CuSO4, and you see that times 5H2O means that there are 5 moles of water attached to this molecule. So it's not just there by itself, it's got the water attached to it. That's why they say when you're hydrated, you're drinking enough water. Um, that's where that word comes from. Anyway, when you evaporate the water, the new substance is known as an anhydrate. That means without water, not hydrated, right? So we've evaporated off the water, then the compound is called an anhydrate. So if you look at these two pictures, this one down here is the hydrate, and then when all that water is evaporated, you can see that the color is gone, and that is the anhydrous version of this chemical. So when you evaporate the water off of a chemical, and basically in your lab, what you're going to do is you're going to try to figure out how much water was attached to the molecules. Um, so have a Bunsen burner. This is called a crucible. It is what your sample will go in, and it will sit on this clay triangle on a ring stand above the Bunsen burner. So you're going to heat this up super, super hot to evaporate off all that water. You always need to remember before you use the crucible to heat it, get it super hot, and then let it cool. That will burn off any impurities that happen to be in there that might have been left from the last person that used it. They will get super, super, super hot, so you need to be very careful. You will definitely burn yourself if you try to touch them without some form of protection. And you also need to remember you're going to heat it up multiple times to make sure all the water has evaporated. And definitely record all measurements. And I can't say this enough, y'all. When you weigh something, you need to write down every number that's on that scale. It is more important that you write all the numbers down than that you get the number perfectly. Like 5.00, I don't care. As long as you're like 5.1 to 4.9, that's fine. What is most important is that you write down the numbers that are on the scale exactly as far out as you can. That is way more important in chemistry than measuring to the exact number that's given in the problem. You want to be close, but you want to be accurate with what you're writing down is way more important. So once you've heated up your hydrate, you've weighed it, you've gotten rid of all the water, you've weighed it again, you can calculate the amount of water that evaporated. So you do that by subtraction. Calculate the mass of hydrate, anhydrate, and water by subtraction. So initial minus the final. And then you find the moles of the anhydrate and the moles of the water. So you'll know what the chemical formulas for both of these are. Just use your periodic table to figure out how many moles. And then you find the molar ratio of anhydrate to water. So you just make that a fraction, reduce it as much as you can. And that will be the ratio. So here's just for an example. We weighed the crucible, got 28 grams, added the sample to it, so the mass of the crucible and the sample was 29.6 grams. Then heated it to get rid of all the water. And after we got rid of all the water, we have 29.24 grams. So then the question would ask, calculate the formula and the percent water if the anhydrate is copper sulfate, or CuSO4. So what we do is first we subtract. We have 1.6 grams of hydrate, so that's my sample before I heated it. After I heated it, it was 29.24 grams. Subtract the mass of the crucible, 1.24 grams of anhydrate. So the difference there is how much water we evaporated. So 0.36 grams of water gets evaporated. Then we figure out the percent. So the amount of water divided by the amount of sample, which is compound plus water, times 100. So this sample was 23% water. Then we can figure out the moles of water. Okay, so 0.36 is grams divided by 18.016, which is the molar mass of water, came from the periodic table, and we get 0.1998 moles of water. Then we figure out the moles of anhydrate, 1.24, that was the weight of that, divided by 159.6. This is the CuSO4 from the periodic table, adding all those up, copper, sulfate, and 4 oxygens. And we get 0.007769 moles of anhydrate. So that's the sample after the water's gone. And then lastly, we make a ratio. So 0.1998 divided by 0.007769, and we get 3, which means for this sample, there are 3 moles of water. So copper sulfate, 3 moles of water attached to it, which we figured that out just by doing all the calculating. So now you should be able to have a good definition of what those two terms are and be ready to start the lab that I think we're doing on Wednesday.